Let's start with our first presenter, who is Evan Marks from University of Vic, who will be presenting about Fertimanure project. Evan?
Okay, thanks, Laia. So good morning, everyone. I'm really happy to be here to be able to quickly present the Fertimanure project. So Fertimanure is an H2020 project with 20 partners from 7 European countries. It's coordinated by Laia, who is moderating here at the University of Vic. So on this first slide, on the right, what we have is a graphic overview of how Fertimanure aims to promote innovative manure management. In the project, we demonstrate how different manure sources can be upgraded with technologies in order to create new fertilizing products for the market. So as seen in the scheme, upgraded manure can be applied directly as bio-based fertilizers to the field, or instead it can be transformed into what we call tailor-made fertilizers, where nutrients are more adjusted to crop needs. So in Fertimanure, we test 2 systems for fertilizer production. One is centralized and also decentralized on-farm production of these TMFs. So the end result in this project is we have new fertilizing products from recycled manure, which promote the circular economy. Next slide, please, Lapo. Thanks. So here's an overview of the challenges and opportunities which we address in our project. On one hand, we all know that there's an increasing global demand for mineral fertilizers paired with resource depletion. We also have regional nutrient imbalances in Europe which need to be addressed, and also a lack of mature technologies for nutrient recovery. There's quite a lot of manure with high nutrient contents generated in Europe each year. And whereas a lot of that manure is just currently directly applied to fields, what we want is to extract those nutrients for higher value products. Other issues which we address on the project level is coming into line with new regulations on the EU level, and also addressing different social barriers in terms of acceptance of these products. So we also have identified particular opportunities which we address in our project. For the livestock sector, we expect that there will be new business opportunities for the creation of these fertilizing products. In the agricultural sector, we need to create standardized, reliable fertilizers. The chemical industry needs to diversify nutrient sources from these organic sources. We expect that technology providers will have new market opportunities to deploy their technologies on farms. And of course, at the end, what we want is for societies to have a more sustainable agriculture and increased food security. Next slide, please. Thanks. So finally, the main outputs of our project. So we have 5 novel technological schemes which we deploy in our on-farm pilots, including a system for on-farm tailor-made fertilizer production. And we create a number of different bio-based fertilizers and tailor-made fertilizers. So we're going to also create a large number of international life cycle data compliant data sets.
Evan, you would have to quick because the 3 minutes already passed.
Okay. And also we consider different business models for all the different actors and a large number of different dissemination products. Okay, so thank you very much.
Thank you, Evan. So next speaker is Mina Sarvi from Luke, and the presentation of Marina is titled Sustainable Manure and Nutrient Management for Reduction of Nutrient Loss in the Baltic Sea Region. So Marina, Mina, sorry, the floor is yours.
Thank you. So I present the policy recommendations of this Interreg Baltic Sea Region funded Sumanu project. And these policy recommendations, they are targeted for more sustainable manure and nutrient management in the Baltic Sea region. Next slide, please. First of all, we need actions both at farm and regional level to get more sustainable manure and nutrient management. And first is farm level. We should raise requirements for acceptable practices and technologies throughout manure management chain, from feeding to manure spreading and use emission-reducing techniques, such as covered manure storages, sufficient manure storage capacity to be able to spread manure in spring and summertime, and advanced spreading technologies. Then manure nutrient content must be determined according to official methods. And finally, we should have regulatory fertilization limit for all phosphorus sources and national fertilization guidelines, both for nitrogen and phosphorus, and these guidelines should take account soil nutrient content. Then there should be annual farm gate nutrient balancing. And based on this calculation, if farm has nutrient surplus, this surplus of nutrients should be reallocated to the another farm. Next slide, please. But if this specific farm is located in the area with regional nutrient surplus, then some manure need to be processed to be able to reallocate it as fertilizer products to another regions. And to create markets for these manure-based fertilizers, we need to support both production and use of them. And we have to also remember and guarantee safety issues while processing manure, especially from different farms and with other co-feedstocks. And prerequisite for this nutrient reallocation is that there is knowledge about the regions where nutrients are produced over the crop need, and also about the regions where there is need for nutrients. And to be sustainable, this use of manure-based fertilizers, they should substitute mineral fertilizer use at the end. Thank you. This shortly.
Thanks a lot, Mina, for your presentation. So now we will hear about Sustainable Biogas Project, and the presentation will be made by Anna Sarentaus from John Nuriman Foundation. Anna?
Yes, hello, thank you. Dear participants, greetings from sunny Helsinki. I'm Anna Sarentaus from John Nuriman Foundation, and I'm here to present Sustainable Biogas, which is an EU Interreg Central Baltic Finance project focusing on nutrient management in the biogas production chain. Next, please. The project is implemented by a Finnish-Latvian partnership, including John Nuriman Foundation and the biogas associations and environmental authorities in Finland and Latvia, and it will be completed next year. And if I summarize the project idea into one sentence, it is that the project aims to promote the sustainability of biogas production from the water protection point of view by paying attention to raw material inputs, operating of the biogas plants, and last but not least, digestate application. And the last slide, please. So sustainable biogas will reduce nutrient discharges from biogas operations by first helping national environmental authorities and biogas operators to plan and operate biogas production in a more sustainable manner. The focus is on learning from best practices in foreign countries and on improving nutrient management at the plants, especially by developing planning, permitting, control and monitoring. The work will result in regulatory and management guidelines for sustainable biogas production, and the results with wider relevance will be published in a policy brief. Second, the project will develop tools for nutrient flow management for the use of biogas plants and environmental authorities. Nutrient balances will be studied in 3 case areas: results in maps showing areas of nutrient deficit and nutrient surplus, and in regional nutrient management plans. And third, the project supports nutrient recycling and market creation by developing digestate quality assurance schemes and providing information on the correct and optimal usage of recycled nutrients. Moreover, plans are made for overcoming current legislative and regulatory obstacles. So please be in touch for more information or check the project website. Thank you for your attention.
Thank you, Anna. Thanks a lot. So now it's the turn of Victor Riau from IRTA, who will be presenting about the Circular Agronomics project. So Victor, the floor is yours.
Thank you very much, Naya. So I think that we can go to the second slide, please. Okay, so in this project, we aim to close the cycles of nitrogen, phosphorus, and carbon along the European agri-food chain. The idea is to increase nutrient use efficiency, increase carbon stocks and soil biodiversity, and also to reduce ammonia and greenhouse emissions from the different practices. And we are doing this by applying some technologies and innovative technologies and some agricultural practices within the 6 case studies among the participant partners. So I have no time, so I would like to show just what we are doing in the case study 1 in Catalonia. So next slide, please. Okay, so in the case study in Catalonia, we are, on the one hand, we are applying precision feeding tools to dairy cows in order to accurately feed the cows based on the daily milk yield, the different weight, body weights, and the individual feed intakes in the feed banks. And the final idea is to reduce nitrogen excretion, and we are comparing this with the conventional feeding system. We have obtained so far reductions of total nitrogen in rain of about 28%, and the comparison of both systems is done also in terms of fertilizer quality of the products. We are applying these both products in ryegrass fields, and we are obtaining biomass yield very similar to that obtained with the use of mineral fertilizers. And on the other hand, we are working on the pig farm, specifically on a biogas plant very close to the pig farm. We are treating the digestate from the biogas plant. We are separating the digestate into a low liquid and solid fraction. The solid fraction is acidified in order to reduce ammonia emissions. Is subjected to the solar drying process, which is mainly a modified greenhouse. And the liquid fraction is subjected to the streaming absorption process in order to recover ammonia sulfate. And we are also mixing the different streams we are producing and subjecting these mixtures to the solar drying in order to obtain high-quality biofertilizers that are being tested in different crop rotations using wheat, barley, pea, and triticale. And we are also testing the phytotoxicity of these products in lettuce seeds in horticultural assays in order to see how how toxic is this product for this kind of plants. And yes, I think that is all from my side. Thank you very much. Very quickly, if you have any questions, of course.
Thank you, Victor. So, well, if anyone has questions, so please write them into the chat, and we will then, at the end of all the presentations, we'll make these questions to each speaker. Thank you, Victor. So the next presentation is about Pegasus project, and it will be presented by Arno Rosmarin from Stockholm Environment Institute. Good morning, Arno.
Good morning. I don't know if you can see a picture of me. I see a picture of
Yes, we can see you.
Okay. Pegasus, that was funded by the IRANET. It's 5 partners. I would just like to say that it emphasized the inefficiency of phosphorus digestion in these 2 monogastric species, pig and poultry, and chicken more particularly. We, at the beginning, spent most of our time on looking at modifications in feed in order to increase efficiency of digestion and retention, and also supplements like phytase and vitamin D and different ways of pelletizing. even breeding and stuff. And the objective was really to try to reduce the amount of P in manure. And so what actually my own personal interest at SEI was really to look at the interaction of nitrogen and phosphorus in this whole element. So tunnel vision of just looking at phosphorus, I don't think is enough. And I think this is reflected in some of the other projects like Sumanu, that you have to look at what happens with nitrogen. If you're going to manage phosphorus, you have to manage nitrogen. And if we go to the next slide, this is sort of thing you have never seen before, but these are isolines for the application according to the nitrates directive of 170 kilos per hectare per year. Here's for the NVZ zones, but for the ones that are not NVZs, you're getting up to 250. And of course, this is probably too low, but 80. The bands here are the N to P ratios for things like X animal pig, X animal chicken, X storage pig. You can see the ratios are very low. They're less than 2 for X storage pig manure. And so what we're looking at, below these lines, you get surpluses. So almost in all cases, if you have like crop offtake of 20 to 30, something like that, you're going to end up with surplus P. So this has to do with the fact that the degraded manure has actually a very low N to P ratio. If you don't understand this diagram, send me an email and we can sit and talk about it for a while. Next slide. So the conclusions from this whole question of N and N losses being the problem with why we have actually P surpluses is that you're losing about 50% of the nitrogen in X storage and X spreading, and resulting in NP ratios that are something around 3 to 1 or even less. And this, if you follow the nitrates directive, you're looking at 170. So we're looking at least 60 kilos of P being spread. And these are causing P surpluses because we're not looking at offtakes that are anywhere near 60. So we have to reduce these N losses in housing, storage, spreading methods, and the treatment that we've heard about earlier today, like acidification, separation, and exporting it off the farm even. HELCOM, which advises on the Baltic Sea, recommends 25 kilos. This is much too, what this will cause if we try to aim and stay with a 25 kilo limit, we will not have enough nitrogen to grow crops. So this will mean that we have to add nitrogen fertilizer. And the dilemma is, and it goes back to what Henning was saying this morning, is the legislation is not really listening. The nitrates directive does not address this question of N and P.
Sorry, Arno, it's, you have already passed your 3 minutes. If you can finish, please.
Yeah, I am at the very end here. Except somebody's put a message over it, what I want to say. The directive, the nitrates directive, it really only looks at nitrogen. It doesn't look at N to P. The farm to fork strategy is also failing to address the N to P question. And I leave that with you as the conclusion from this presentation.
Thanks a lot, Arno. So we go now, our next speaker is Alla Silkina from Swansea University, who will present the ALG-AD project. So Anna, good morning. Alla, good morning.
Thank you, Leah.
Thank you.
Yeah, my name is Alla Silkina. I'm presenting ALG-AD project. Lead partner is Swansea University in the UK. It's Interreg project. We kind of in the final year of this. So the aim of the project is to creating value from waste nutrients by integrating algal technology and aerobic digestion technology. So please follow our project on social media. We're really active. We have different webinars and events, and lots of video already recorded. And next one. So next slide, please. So in some numbers, so this is a 6.2 million project, 4 years project. We have 11 partners across Europe, UK, France, Belgium, and Germany. So we're growing algae using nutrients from the excess of digestate coming out from the anaerobic digestion plant and use this biomass as an animal feed ingredients. So objectives is build 3 pilot facilities, install them in industrial location in France, Belgium, and UK, convert digestate to the algal biomass by successful growth and remediation of these nutrients, develop into animal feed products. So we use the biomass, fractionate this biomass, hydrolysis, and so on, and basically compiling all the data from 3 pilots and all activities of the project, and one online tool, what is called decision support toolset, that will help future stakeholders to think about investment on this technology and what is potential CapEx and OpEx will be need to be required to get successful business based on this data. Next slide, please. So one of the main output for us is also was to touch base on the regulatory review. As you all know, and everyone mentioned as well, it's really special aspects in this, because it's in a way kind of stop us to get this technology development and activity spreading. So basically, talking about algae using digestate and further development of the products from it. So it's no specific framework. This is the highlights from the specific review where we did. So despite treatment safety analysis and different transformation, we're not allowed to use biomass, algal biomass, using aerobic digestion come from the feedstock with animal byproducts. So any of this, so even including category 2 manure. If a digestate from the plant-based input and category 3, excluding catering waste, can be used. So this is quite important point for us, so that we can progress further. For the biomass produced on the first case, so the alternative markets was investigated. So we just think it's like the feed for non-food producing animals, for example, pets and zoo animals, or also we can use this biomass for biostimulants and not promising market, and basically most promising market, and no authorization is required. So if you want to get access to these reports and all other reports from the activities of the project, please go to our website, request this, and we will send this forward. So thank you very much, and we'll be happy to be in touch and answer the question later.
Thank you very much, Jala. So now it's time for Jonathan Slaken from University Rostock AgriPlus. Jonathan, you have 2 minutes instead of 3 minutes. I guess you are aware of that. So yes, the floor is yours.
Okay. Thank you very much for the introduction, and also for the opportunity to briefly introduce you into one of the Phosphorus Science Campus projects on how to recycle excess phosphorus from aquaculture sludges. So basically, our main objective of this project is to evaluate the peer recovery potential of sludges accumulating and recirculating aquaculture systems known as RAS. And in this context, we are mainly focusing on the different steps needed to produce those peer recyclates, which are first the mobilization of the phosphorus from the accumulating sludges, the precipitation process, and finally the extraction and isolation of the synthesized products. And in addition, the digestibility and also the bioavailability will be analyzed to evaluate the usage possibilities, and eventually we will conduct an economical evaluation. And in our project, we've adopted a wet chemical peer recovery technology, which is composed of 3 main steps. So firstly, the aquaculture sludge is mixed with an acid to lower the pH and start the mobilization process. Secondly, natrium hydroxide and or calcium hydroxide, depending on the calcium concentration in our solution, is added to increase the pH and to initiate the precipitation process. And finally, the solid and liquid phase get separated to receive the P recyclates as monocalcium phosphates or decalcium phosphates. And in order to be able to assess the total P quantities that can be recycled in recirculating aquaculture systems, we conducted a mass balance trial that you can see in the left bottom corner, in which we measured the total phosphorus loads of such a system, and which leads me to my conclusions. What we found out is that around 25% of the P input was discharged as output into the wastewater treatment plant. However, the sedimentation reactor only had an efficiency of around 0.5, so there's still a big increased potential where we will focus on the future. And furthermore, with our developed peer recovery technology, up to 86% of the phosphorus could be recovered from the sludge which eventually accounts for approximately 0.65 tons of pea recovery in a commercial land-based aquaculture system, which is pretty good. So that was a quick overview of our project. And if you want to get more insights, you can contact me directly via LinkedIn or email or follow our Leibniz Science Campus Phosphorus projects. Thank you very much.
Thank you very much, Jonathan. So now I would like to give the floor to Jennifer Bilbao from Science Europe Centrum, who will do the presentation Ecological Nutrient Recovery from Agriculture in the Hohenlohe region. So Jennifer. Jennifer,
yes, can you hear me?
Yes, now, yes. Thank you.
Okay. Hello, everybody. My name is Jennifer Bilbao, and I coordinate the group Circular and Bio-Based Economy at Steinbach Europe Center in Germany. It's a consulting company helping innovators to grow. In this framework, we are involved in the 1.7 million euro EIP Agri project, Agri Plus, and this is a European Innovation Partnership project co-financed by the European Union and the state of Baden-Württemberg in Germany. The overall objective of our project is to increase the efficiency in arable farming through improved nutrient management in the region Hohenlohe in Germany, which is a region with intensive livestock production and therefore characterized by an excess of manure and nutrients. For that purpose, we have built and are now validating a full-scale plant with a capacity of 10 tons per hour to recover products of digested manure. This technology is the result of more than 10 years research and is built on different chemical and mechanical processes, in which from 10 tons of manure, we are able to obtain 100 kilograms of mineral phosphorus fertilizers, 150 kilograms of nitrogen fertilizers, and 1 ton of organic peat replacement material for horticulture. Our colleagues from the University of Hohenheim are then testing at large scale these products in cooperation with farmers of the region. Next slide, please. With this AgriPlus, tackle the challenges of excess manure in regions with intensive livestock production in 3 ways. It is an efficient process which enables us demand-driven fertilization in other regions with nutrient demands. We have environmental advantages as well, as less mineral fertilizers must be produced. We have a better groundwater quality and less manure transportation, which in total leads to a reduction of CO2 emissions. And we also have economic advantages, especially because the manure disposal costs are pretty much reduced. If you want to learn firsthand from our project, we kindly invite you to our conference and plant tour, which will take place in autumn this year in Hohenlohe, which is in the south west of Germany. And we will have a technical meeting, but also an event targeted for policymakers. So more information on the program we will publish soon, and we will let you know about this event. Next slide, please. With this, I would like to thank our sponsors and partners for their great contribution in our project. And if you have further questions, you can contact me anytime or the lead partner, Thomas Karle from the company Agroenergie Hohenlohe. Thank you.
Thank you very much, Jennifer, for the presentation. So now it's time to hear about systemic projects. So Oscar Schaumans from Wageningen University and Research. The floor is yours, Oscar.
Yeah, thank you very much, Laia, for this introduction. I'm Oscar Schaumans, working at the Wageningen University and Research, and I'm coordinator of the systemic project dealing with large-scale eco-innovation to advance circular economy and mineral recovery from organic waste stream. And you see our picture over here. We are starting with large-scale digesters, which are available in many places, and we have selected 5 and implemented on those large-scale digestate biogas plants nutrient recovery technologies in order to showcase, demonstrate the impact of nutrient recovery. And we want to develop a roadmap for the transition towards a circular economy for nutrients from organic waste stream. Next slide, please. Systemic in a nutshell, we are dealing with really visionaries, pioneers, demonstration plants. We're looking at the nutrient recovery at those large-scale plants, the performance, the product quality, and the economical response. Of course, also looking into sustainability approach, environmental impact assessment and life cycle assessment, and also the economical feasibility for those plants is really important. Looking into the business case, national support schemes, and how to implement it on a regional scale. A big aspect is also the dissemination to other outreach locations, other biogas plants. We have now 28 plants involved over here, looking at the outcome as first followers. And we are emphasizing also regarding fertilizer product regulation, nitrate directives, in order to minimize the barriers for the implementation on a regional scale of the new technologies. Next slide, please. We are dealing with different type of feedstock, not only manure and poultry litter, but also sewage sludge, energy crops at those biogas plants, and agro-industrial residues. And the main technologies are dealing with reverse osmosis, evaporation, condensation, and nitrogen stripping, and also phosphorus stripping. The products that we are producing are mineral concentrates, ammonium sulfate, calcium phosphate and struvite, organic fertilizers and soil improvers, and also organic fibers as peat substitute. And finally, last but not least, also renewable energy, because we're dealing with biogas plants. Our conclusions, we started in 2017, we are now in our final year. All large-scale plants up to 250,000 of tons of waste treatment are running, and the plants have to be market orientated. Just producing bio-based products is no guarantee to survive. It has to be implemented and linked to the market. Bio-based nitrogen fertilizer can compete with synthetic mineral fertilizers in all cases that we showed. And recovered phosphorus as secondary resource for fertilizing industry can be used, but also for direct application in P demanding areas. And there are very much new possibilities for organic fibers after nutrient recovery treatment processing. There are high risks.
Sorry, Oscar, we are
last one.
Yeah, great.
High risk for the investments of nutrient technologies, and yet the market is not developed for bio-based and tailor-made fertilizers, and new incentives are really needed to stimulate broad implementation of circular economy, which was discussed last week also with policymakers in the circular economy workshop of Systemic. Thank you very much for your attention.
Thank you, Oscar. So now it's time for the last presentation that will be made by Erik Sindorch from Research Institute of Sweden. Erik, I guess you also know that you have 2 minutes instead of 3. Hello, Erik. Are you here?
Seem to be having some difficulty with technical
Yes, we can
issues.
see and hear you.
I don't know if my microphone's working.
Yeah, I can hear you, Erik.
I can't hear anybody.
No?
Can you hear me, or you can hear me?
Yes, we can.
Well, I'll just go ahead and say it then, even though I can't hear anything in response. But yes, this is just a one slide. The project just started a couple months ago, so we have no results to present. But essentially, a situation in Sweden is that manure spreading from livestock is regulated by phosphorus application limits of a maximum of 22 kilograms of phosphorus per hectare per year. And these limits can be even stricter if soil phosphorus levels are high. And this is often the case for farms with a long history of livestock production. So these restrictions on phosphorus applications for manure are creating restraints on livestock production. So the main focus of this project is to deal with this phosphorus issue. Now that's an interesting, I'm not quite sure what that is. That next build picture. But
I'll share your screen again. I shared the slide again, I'm sorry.
Okay, well, I didn't get the technical issues taken care of.
There you go.
Or is that my slide? This is a bit frustrating not to be able to hear anything.
Can you see the slide?
But the main focus of the project is to try to take away some of the phosphorus and transport it to areas in Sweden that need phosphorus, and then to improve the nitrogen use efficiency of the liquid fraction, which will go back to the farmers. And we're going to be focusing on looking at the market potential, trying to find buyers for the products, testing a suite of different processing techniques to produce products, and looking at the agronomic potential of it and so forth. But we'll come back with more results later. Thank you, if anybody heard any of that.
We heard you, Eric, so it's a pity that you cannot hear us and that you have these technical problems, but at least we could hear your presentation. So thank you very much, Eric. So with this presentation, we have already finished the presentation of all the research and development projects that we had for this manure session. So thanks again for all the presenters for letting us know all what you're doing in your project. So now we have time for some questions. So I cannot see any questions in the chat. So I don't know if some of the attendants of the session would like to ask something or make some comments. So if you want to raise your hand, and we can give you the word, and you can do any comments or questions that you may have. Marina?
Yeah, may I start with some questions? From what I see in all of these projects is that we are very eager to develop the technologies and interesting products and so on. But my question is obviously related from the user, being from the industry. So what about business case from the perspective of the requirement of the market? So if projects are maybe targeted to what kind of products in the end are not only nice to have, but also high value products, for instance, and can we include this in the business cases of these projects? And yeah, so I think this is a nice intro question to everybody.
Yeah, it's a good thing to raise, and it would be nice to know about what our speakers think about it. So I don't know who, Evan wants to go first.
Hi, thanks, Laia Marina, for the question. Yeah, so this is actually an aspect which we do consider in Fertimanure. We carry out different studies of society, the market, with different stakeholder groups in order to address specifically that topic. Because eventually, of course, what we need for our projects and the concept to be successful, as was mentioned in one of the previous presentations in the first session, it all depends on user uptake and actually user acceptance. So definitely agree, and that's something we hope to be able to address adequately in Fertimanure.
Thank you, Evan. So we have two other hands. The first one that I've seen is Ala Silkina.
Yeah,
Ala.
I would just like to add as well. Yeah, absolutely right with the high value products. For example, in our case, when we grow microalgae, I mean, the essential fatty acid is good for animal nutrition and is required because we have scarcity of this source. But regulation at the moment is not allowed us to go further, and just we need to address the issue related to these questions.
Thank you. So Oscar, you also wanted to comment something?
Yes, also a brief comment on the question of Marina. I think regarding the systemic project, if you are dealing with large-scale biogas plants and you include nutrient recovery technologies for the treatment of waste for more than 100,000 up to 250,000 tons of manure or whatsoever, then you have to deal with the market. Otherwise, you can't get rid of your product. You can't make profit of your products and reuse it in a way it should be used. So all of these plants are market oriented on their own region, where they get the supply of feedstock for the plants, and also direct interaction within the farmers within the region. They even make nutrient management plans for application of the products in real field scale, and tests are being done. Other products comparable with synthetic fertilizer, synthetic mineral fertilizer. So from that point of view, it was also a conclusion from the systemic plant, just producing bio-based fertilizer is not, you won't survive as a large-scale plant. It's impossible.
Thank you, Oscar. Is there any other project that would like to comment about including this business model or business cases in the project? Okay, well, Marina, at least we heard about 3 of our projects. In case anyone else wants to say something about it, you can use the chat or also the Google Jamboard. And I've seen now in the chat that Evan has a question for Ala from the Swansea University. So Evan, if you want to make the question to Ala.
Okay, yeah, thanks. So Ala, thanks for your presentation. And just I'm very curious about the application of algal technology, particularly for these highly organic matter-laden nutrient sources that I believe you're working with. It seems like that you have to overcome for large scale algal production, you have to overcome a number of challenges, I imagine. But I guess you could tell us, for instance, the high contents of dissolved organic matter, particulate matter, which of course influence light diffusion and photosynthetic activity and those sorts of things. From what I understand, I don't know whether the solution is dilution, as they say, or whether you have other techniques. Thanks.
Thank you, Evan. It's really good question, so definitely, especially we locate our pilot plants in industrial location. It's far from laboratory university setting when we kind of everything is clean and shiny, So, but definitely, so when we're dealing with digest state, we need to pre-treat it for sure, because otherwise algal process could be not successful in this case. So we did dilution, and this is the important step, because amount of nitrogen and phosphorus, as you know, is really high than even large-scale cultivation facilities of algal cultivation could not take all of these nutrients. And we also use membrane filtration, because it's an important step to avoid toxic and just color cell removal and some other things. So in this case, we get successful results of obtaining a high level of algal biomass. However, we can't remediate big amount of nutrients. As I mentioned, we can remediate only excess of nutrients, coming out from the anaerobic digestion plant. I hope I answer.
Thanks, thank you, Ala. So sorry that I missed one question that was for Arno. So the question is, you mentioned that the farm to fork strategy doesn't take the NP problem enough into account. What steps do you think they have to take to address the topic better?
Thanks a lot, Jasmine, for that question. The N to P ratio is really critical when applying fertilizer, because you want to feed the crops with exactly what they need. The nitrates directive does not provide any kind of guidance on that. It just says put a maximum of 170 kilos per year on hectare in NVZ areas, in the vulnerable areas. And on the other side, the Water Framework Directive says, do not pollute with phosphorus. So these are conflicting directives. The farm to fork thing is a strategy, and it somehow is going to find its way into the directives. What we need are farm gate balancing methods and indices, ways for the farmer to know when he's going to or she's going to be violating these directives. Many of the countries don't have national regulations on phosphorus limitations and surpluses, and they just use the nitrates directive. So they are violating the Water Framework Directive. And we will continue to have green water full of algae until we get this thing straight. And I don't think the solution is going to be exotic ways of producing new products when we have some basic farm gate methodologies that we can have to look at the limits of what we can do with manure. Then after that, we can talk about extraction and product. Okay.
Thank you very much, Jasmine, for the question, and also Arno for your answers. So is there any other questions or comments that you would like to make? Marina, I see that you are unmuted again.
Yeah, I indeed have another question, which might be a bit provocative. We are talking a lot about phosphorus and nitrogen, of course. What about potassium? Has anybody potassium also on the screen?
Any answers for Marina?
Yeah, I do have an answer on that. First of all, most or all water bodies are not, there's eutrophication is not caused by excessive potassium. And it doesn't accumulate in manure. It's highly water soluble. So potassium actually is ubiquitous, and it's not really a big problem. I would say sulfur is probably more limiting than potassium. Maybe there's an agronomist that can add some facts about that.
Yes, if possible, I can answer her. It's Daniel Elchami from Team Agro.
I cannot hear you very well.
I can answer her.
Okay.
Can you hear me now?
Yes, better. Yes.
I'm Daniel Elchami from Team Agro. We are specialists in nutrition, and the potassium is not a problem in soils. First, because it's not mobile as an element. Second, because there is a tendency to not to give the right amount of phosphorus, because soils normally were rich in potassium. So there is no excess of potassium in soils. At the contrary, sometimes there is deficiency. So it's not a problem for groundwater and soil pollution.
Thank you, Daniel. Any other project or speaker that would like to comment about if they consider potassium, or how do they consider it, or if you are mainly focused on nitrogen or phosphorus? So
maybe a remark from the Netherlands, Laia. We're looking at nitrogen, phosphate, potassium, and sulfur, all aspects, and I agree, potassium is not really an issue in most cases. In the Netherlands, we have both nitrogen and phosphate legislation for the whole of the Netherlands, because the whole of the Netherlands is a nitrate vulnerable zone. So from that point of view, we are really looking at the pollution of groundwater and surface water, especially regarding nitrate concentration, groundwater and surface water quality. Sulfate is an issue. to my opinion, especially if we are going to use nitrogen recovered from different type of waste streams. We make ammonium sulfate, and if we don't take into account the amount of sulfate required for the crop types, then there will be a complete imbalance. Arno was discussing the NP ratio. In fact, to my opinion, for all macronutrients, including carbon, we have to set up a new nutrient management strategy. Because also from the farm to fork strategy, the zero pollution, we have to reduce the amount of nutrients applied to the soil with 20%. So from that point of view, we need to improve our nutrient use efficiency for all elements in order to get a better performance on our agricultural land, to my opinion, and less losses. So not only dealing with NP, I fully agree, Arno, but also looking at sulfate and carbon is important.
Thank you, Oscar. So Evan raised his hand.
Yeah, just a final quick comment regarding potassium, the potassium situation in terms of regulation here in Spain. So for Catalonia, the most recent fertilizing products regulation, or regulating organic fertilizer application, one novelty in 2019 was limits and controls monitoring for soils where there's applied different subproducts, such as the waters from nitrogen denitrification plants. So in that case, there are maximum allowed levels in soils just to limit over accumulation of potassium. So this kind of gives the impression that this could be something that, at least from a soil quality perspective, may be more controlled in the future. And also lastly, well, in the Fertimanure project, we also do carry out balances of potassium, and different technologies are more or less, depending on the system, more or less optimized to separate that resource.
Thank you, Evan. So Jennifer Bilbao, if you raised also your hand.
Yeah, I wanted to comment also on potassium. So in the Agripulse system, we separate phosphorus and nitrogen as a fertilizer. So the first one is a dry fertilizer, phosphorus, and the other one is ammonium sulfate. And potassium actually is, so as we separate everything, all the organic on all phosphorus and nitrogen from the liquid phase, then we have some potassium in the liquid phase, but the concentration is too low to really recover these as a dry fertilizer. So we just leave it in the water, and this serves as an irrigation water for the communities that are nearby, near the plant. So just to comment what we do with the potassium, but it's recycled into the agriculture again.
Okay, thank you, Jennifer, also for your comments. Next, I see in the chat a question made by Elaine Jukers. So are the fertilizers effectively mineral fertilizers, so therefore do not supply any organic material, which could be beneficial? So I guess, Elaine, that this is a question, a general question for the project. So if anyone has something to say about this question, that would like to explain which type of fertilizing products are you recovering, if they are mainly mineral or also consider organic matter.
Yes, in circular agronomics, we are, as I said before, we are producing both. We are producing mineral fertilizer, bio-based mineral fertilizer in the form of ammonium sulfate by the stripping and sorption process, and we are also producing biofertilizer, organic biofertilizer in this case, by the solar drying process. We are also obtaining manure from the precision feeding system with less nitrogen content. So this have a positive impact also in the emissions of ammonia during the storage and during the field application of these products. But in this case, we are using both, and we are comparing the products we are obtaining with the mineral fertilizer, the commercial mineral fertilizer. And I said before, we are obtaining very good biomass yields, very comparable with the mineral fertilizer application. Yes, it's only.
And yeah, in our project, we are also focusing on in our project where we are focusing on the peer recovery of the RA sludges. We will also, after the mobilization, the precipitation, we will receive a pH liquid phase that where we want to extract the phosphorus from. And after that, when we dissoluted all the elements that are usually bound in the solid phase, we will also receive a organic or a carbon-rich solid phase that we can also maybe use in the agriculture to put some organic matter or put some carbon into the ground, to the soil.
Okay, any other comments from other projects? Okay, so a new question here in the chat. So considering the NP ratio, should focus be on any specific manure type, pig, cow, poultry, or are they all equally relevant? Anyone who wants to comment on this?
Just to say that the NTP ratio is more critical for the monogastric species, the pig and poultry, and you will get higher NTP ratios in the ruminant type manures. So if you ask any farmer, they'll say, what's your favorite manure? And they'll always say cow. So, and the biggest problem is the high density, the LSUs of the pig and poultry industry, because they are exceeding the carrying capacity of the hectares for those farms. So inherently, they're designed to produce phosphorus surpluses, because that's all that's left, and lots of nitrogen losses, 50% nitrogen loss through gaseous losses, nitrous oxide, ammonium, nitrogen gas, and even nitrates if the storage is very poor. So cows first, pig second, poultry third.
Any different comment, any other answers to this question? So if not, we go to the next one. So it's over-fertilization with manure. Nutrient-balanced fertilization. Will EU Farm to Fork set target goals for fertilization to avoid over-fertilization? Anyone who wants to answer this question?
I'll wait for someone to answer. I don't want to dominate this, but
no problem.
We just put in for a project to try to beef up the farm to fork strategy, because it's lacking exactly on that point, Gunnar. And it really comes down to balancing at the farm gate. So, and it's nothing new. Maybe it's late in coming to some of the European countries. It was a huge thing in North America. I think they really got it right, but it's complicated. So the farm to fork strategy is not actually emphasizing balancing enough. And so we're stuck with the nitrates directive, which is really a nemesis. And I think, I don't know how we're going to get out of this thing. It's politicized. And basically phosphorus is hiding under the carpet and is not being taken on seriously by many countries. I mean, some of the countries have national regulations. Around the Baltic, there's a few. You know, leaders like Holland, for example, definitely. But many say, no, phosphorus I don't have to worry about. I just manage my manure on the basis of the nitrates directive. And that is where the farm to fork thing is pretty useless. It's going to end up just defaulting on that. So it's a flag, but there's not much to it.
So thank you, Arno. I don't know any other comments, answers to this last question. Any other questions that, okay, Oscar?
Yeah, just one point to add to what Arno said. I fully agree with him. However, when we are talking about nutrient balancing, it's most of the cases it's dealing with the farm scale itself. And to my opinion, the amount of P accumulation in the soil is very important and should be taken into account into those balances, because we have to reduce the amount of P in the soil in order to reduce the losses to surface water. So just balancing now from what's going in, what's going out is not sufficient for phosphorus if you don't take into account the amount of P accumulated in the soil already.
Correct.
Okay, so thank you, Oscar. Any other comments, questions that you may have? Okay, there's a new question. Is there any way recycled manures approach can work with mineral fertilizers? It isn't possible to combine organic materials with ammonium nitrate, dangerous, but can extracted materials be used? It might provide an investment opportunity for manufacturers. I think one is looking at this already. Anyone that would like to answer Eleni question?
Well, I can answer if I may. Actually, the private sector is looking for new raw materials, and we are getting involved in many projects to check the validity of products and formulas for the consumers. So yes, there is a need for the private sector in these materials.
More comments? Marina?
Yeah, this is in fact a very interesting one. I think this has to be carefully evaluated per case. And this is, from my understanding, exactly what is now defined in the list of material categories, which then have to be finally have to get an end of waste status, and then it is allowed, according to my understanding, to be used for the production of a fertilizer. And then there is a mixture possible of different materials, but only if this is achieved. So it is there a lot of quality requirements have to be fulfilled for this, and it has to be listed. And this is an ongoing process, according to my understanding. So we as an industry are carefully looking what is happening here, and of course trying to support this idea. This is the interesting point in the end. So what I see is that there are many products in the end coming out from several initiatives, but from what, for instance, Yara is selling, these products are not completely according to the market demand on different areas, let's say. And if we then are allowed to create a new fine-tuned fertilizer out of this, this would be the ideal case, of course.
Thank you, Marina. Evan?
Okay, yeah, so to respond to this point, this is specifically also a challenge that's taken up by the Manure project. Going back briefly back to my presentation, I talked about what we call bio-based fertilizers, which are for us the raw materials, which are the first step following some sort of transformation, physical, chemical. And then what we are trying to do is and some of these bio-based fertilizers can be of a high mineral content, high purity. For instance, ammonium sulfate from scrubbing. So what we are actually working on is then combining these different products and different arrangements in order to, both so that they are functional fertilizers which don't present any risks and can be physically combined to create a unique single product which can then be destined to a given crop. I hope that answers the question.
Yes, I have a comment also. In the circular agronomics project, we are doing also this. We are mixing the different streams from the stripping scrubber process. And we are mixing this with the organic product, and we obtain the solid fraction we obtain after centrifugation. And we are now doing this, so we have not results yet. But the idea is, of course, to obtain only a final product, very dry product with about 90% of dry matter that can be used as a solid fertilizer, of course. So yes, this is one option we are working on. Yes.
Okay, thank you, Evan, Victor. Okay. I see there's a comment, but I don't think it's a question. Any other questions? So we have 5 minutes. Do you have any other questions? If not, okay, Marina, yes?
Sorry. A final one maybe, and this goes to the terminology of definition terms we are using, and also in combination to what we heard this morning, that the regulation is sometimes, let's say, a bit apart, or it's a struggle, an issue to provide the policymakers with our results or what we want, let's say. And I was a bit struggling with the term tailor-made fertilizer, TMF, because I thought in the regulation vocabulary it is called organo-mineral fertilizer, or mineral fertilizer, or organic fertilizer. So it's just a question, is this clear term already? Is this established, or is it a new one, or it's just project related for manure or whatever?
Evan?
Yeah, thanks, Marina. So for the moment, I think this is a terminology which we've employed in manure. What we want to do with this term is to explain an organomineral fertilizer, as you correctly state, it's a product combining potentially mineral, organic, different sources. However, what we want to emphasize with this term is to create a situation where there's flexibility for production, both at the for larger companies, also for farmers, in order to be able to mix adequately different inputs to adapt to different crop needs. So it's not one organomineral fertilizer on the market, or perhaps one company markets one organic mineral fertilizer. We basically have the vision that you have a process, a downstream processing fabrication, which has an inherent degree of flexibility for adapting to farmer needs. That's basically the idea. But of course, if you look at the legislation, tailor-made fertilizer does not appear. It's true. I think Oscar also has something to say.
Yeah, from the systemic project, the experience is not from fatty manure, where we are part, also project partner, but within systemic, we also developed a procedure to reach the farmer with a nutrient management plan. Even the tailor-made fertilizer or the custom-made fertilizers are changed during the growing season in order to meet with the crop requirements. For instance, for grassland, the first two cuts of the grass, sulfate is needed, but for the other cuts of the grassland, no additional sulfate is needed. So you have to make it tailor-made, customized during the growing season to apply exactly the amount of nutrients for that moment for the crop type. So it isn't, like Evan said, it's not a general product, but you have to make it taking into account the farmer itself, the timing in the growing season, how the products from nutrient recovery technologies has to be blended or combined, or can't be blended, has been separated, applied to the land in a way that it will be optimal used by the crops and have the best benefits. So there is, to my opinion, no universal definition for it, but tailor-made is tailor-made, looking from the farmer back to the producers of bio-based fertilizers and making the right combinations.
Okay, thank you, Oscar. Any other comment related to Marina's question? So if not, I think that we have reached the end of our parallel session. So if some of you had any other comments or questions, so I would invite all of you to connect to the link to the Google Jamboard, because we have had a discussion and it has been really nice with different interesting questions, but it would be nice if you can take some time now that the session will be finished to enter in the Google Jamboard link and put here some keywords, some conclusions, some challenges that you think that would be relevant considering what has been discussed in this session. So also if you had any other things that you would like to comment and we didn't have time to address it, please go to the Jamboard and put it there. And then this afternoon, Marina, as the rapporteur of our session, will summarize and present our main outcomes. Okay? So I don't know, Lapo, if you want to say something related to the organization.
Thank you very much, Lai and Marina. You've been wonderful moderator and rapporteur. Thanks to all the speakers. You've been delivering very interesting presentation, raising many insightful points. Thank you to all the attendees who stayed with us. So now we have a 2-hour-long lunch break. So you can do one of three things. You can either simply stand up and go enjoy your lunch break, and you can come back by 2 p.m. when the closing session will start, and you will find yourself into the main session, since the breakout sessions will be closed automatically. You can or also leave this breakout room and already go back to the main session, and then you can stand up and go enjoy your lunch break, and then you can come back by 2 p.m. Or you can leave the Zoom meeting altogether, and then you can use the same link you used this morning to join the Zoom meeting for the first time, and you will find yourself in the main session where the closing plenary will take place. So it's up to you, and I wish you all a nice lunch break, and I'll see you all in the closing session.
Thank you very much, everyone. We'll see you later.
Thank you very much.